talking about snakes. Dozens of snakes were released into the wild in North Florida to eat other invasive snakes.
Yeah, okay, the ones that were set free were raised in Lake County and then brought up there.
A strange humming settled over the edges of the Everglades on the morning the canisters were opened. Park officials, biologists, and carefully vetted journalists watched from a restricted shoreline as the airboats drifted into position. They were armed not with tranquilizer rifles or nets, but with sealed metal cylinders chilled to preserve the delicate biological payload inside. Nobody spoke, not because of secrecy, but because of the indescribable tension that weighed down the moment. Something unprecedented was about to be released into one of the most ecologically stressed regions in the country.
But the Burmese python infestation in Florida is far from a work of fiction. Wildlife biologists in the Sunshine State are deploying a new weapon in an effort to eradicate this threat to the Everglades.
And everyone present understood the gravity of that decision. Before we start, smash the like and subscribe buttons for more updates. The Everglades had been losing its ecological balance for decades. Burmese pythons, introduced through a mix of illegal pet dumping, hurricane-damaged breeder facilities, and careless experimentation in the exotic animal trade, had multiplied uncontrollably. They were apex predators in a place that had not evolved to withstand them. Marsh rabbits vanished, deer populations shrank. Even alligators fell victim to the constricting coils of massive serpents that had no natural enemies here. Ranger reports read like ecological obituaries, each year marking new declines. Trapping helped but barely made a dent. Hunting initiatives created public engagement but could not outpace python reproduction.
I have no idea what part. I got him.
Go. Oh, nice.
The ecosystem couldn't wait another generation for an answer. That pressure gave rise to a team of molecular ecologists and wildlife disease specialists who proposed a radical solution. The idea was simple in theory, yet dizzying in its complexity. It centered on a biological agent tailored to target the python's unique physiology while leaving other species untouched. Not a poison, not a trap. Something internal, something that used the python's own genetic and metabolic quirks against it. The research began quietly, shielded from public attention, to avoid misunderstanding and sensational panic, yet also to prevent misuse. Years passed before the concept moved from laboratory petri dishes to controlled test enclosures. At every stage, the goal remained laser-focused. Engineer a biological mechanism capable of disabling invasive pythons without creating broader ecological chaos. The final product, if one could even call it that, resembled a microscopic saboteur. Harmless to mammals, birds, and reptiles outside the target family, it interacted with an internal system virtually unique to large constrictors. Once inside a python's digestive tract, the agent triggered a chain reaction that disrupted key metabolic pathways essential to its survival. It didn't release toxins or spread uncontrollably. It couldn't reproduce outside its host and was incapable of jumping species. It had a built-in biological clock that ensured it degraded within days. The team's precision was extreme, shaped by intense oversight and relentless ethical reviews. The foremost requirement was safety for everything except the invasive predator ravaging the Everglades. As the first canister was cracked open on the airboat deck, a faint mist rose into the humid morning. It drifted only a few feet before settling on the water's surface. The microscopic particles bonded quickly to organic material floating in the marsh. Any python hunting along its usual routes would ingest them naturally. The scientists had studied snake feeding behavior meticulously to ensure predictable contact. Pythons swallow prey whole, and their stomachs create an environment ideal for activating the agent. The very digestive power that allowed them to consume deer helped ignite the mechanism designed to stop them. Those watching from the shoreline felt something shift when the mist dispersed. It wasn't triumph exactly, it wasn't relief either. It was more like the realization that there was no turning back. The action had been set in motion. No one knew how quickly visible results would appear, though early trials suggested a window of days to weeks. The Everglades, always alive with unseen movement beneath the water, felt momentarily still, as though the environment itself was waiting to witness what humanity had dared to attempt. The weeks leading up to the release had been filled with debate. Supporters argued that the Everglades could not endure much more devastation. Without decisive intervention, keystone species would continue to vanish, and the food web would collapse in ways far harder to repair. Opponents raised concerns about new technologies in natural spaces. Even with targeted precision, any biological agent released into the wild carried philosophical weight. What did it mean for wildlife management? How would society reinterpret conservation if gene-tailored organisms became common tools? These debates didn't prevent the release, but they lingered like a charged haze around the entire initiative. The leadership overseeing the project knew they were walking a razor's edge between scientific necessity and public trust. Transparency had to be balanced with caution. The full genetic blueprint of the agent remained locked behind layers of cybersecurity. Only a handful of researchers knew its complete design, and access was monitored constantly. The state coordinated with federal agencies, environmental groups, tribal representatives, and bioethics boards to ensure safeguards were exhaustive. Every document reflected the same principle: intervention must not become a destructive habit. Each case must be exceptional, scrutinized, and constructed with restraint. Inside research facilities, the months before deployment were marked by exhaustive simulation. Scientists recreated wetland conditions in controlled, biosecure rooms. They introduced organic muck, rotting vegetation, swamp water, and even environmental fluctuations like nighttime cooling and sudden storms. They tested the agent's longevity, how quickly it broke down, how much ultraviolet light affected its structure. They looked for unlikely interactions with native reptiles such as indigo snakes and king snakes, which occasionally ate juvenile pythons, to confirm that cross-species activation was impossible. Only when every variable satisfied the strictest safety thresholds did the environmental regulators authorize the field release. The morning of the operation had the eerie quiet of a historical turning point. Airboats glided into remote channels inaccessible by foot. Drones hovered high overhead to document dispersal patterns, temperature shifts, and atmospheric diffusion. The mist released from the canisters wasn't dramatic. It didn't glow or smoke or ripple like cinematic biotech. It simply drifted, settled, and disappeared into the water, leaving nothing visible behind. The subtlety of its presence contrasted sharply with the magnitude of its purpose. As more canisters opened, technicians monitored environmental readings in real time. They watched for changes in water chemistry, microbial activity, and oxygen levels. Their tablets showed stable readings, confirming what years of modeling predicted. The agent remained inert until ingested by a python. The stillness of the marsh became the backdrop for one of the most meticulously orchestrated wildlife control operations in history. The release spread across a strategic grid, targeting territories mapped through decades of python tracking. Researchers knew where females nested, where males roamed during breeding seasons, and where juveniles dispersed after hatching. These behavioral patterns shaped the deployment zones, increasing the likelihood that pythons throughout the region would encounter the microscopic solution. It was a biological chess move on a massive scale. Long before this day, the python problem itself had taken on almost mythical proportions.
Or snakes. It's a phrase that may make some shudder, but local biologists say it's necessary.
Working to help balance that ecosystem back out by reintroducing the eastern indigo snake.
Hunters pulled 30-foot serpents from marshes. Roadside sightings became more frequent. Stories circulated of entire alligator nests vanishing overnight and marsh bird colonies dwindling. Biological surveys captured the staggering impact: a near 100% decline in raccoons and possums in some areas, a 90% decline in bobcats, and severe disruption to wading bird populations. Researchers posted camera traps only to find python after python slithering past. These data weren't abstract statistics, they were harbingers of an ecosystem unraveling. Restoration efforts had long been tangled with legal, environmental, and logistical challenges. Removing an apex predator, even an invasive one, was never simple. Killing them manually wasn't enough. Relocation was impossible. No region wanted a new population of voracious constrictors. Captive containment required enormous resources. The biological agent, though controversial, represented the first tool with the potential to address the problem at the scale required. After the release, the monitoring phase began. Immediately, teams spread throughout the Everglades, setting up checkpoints and scanning for environmental anomalies. Rangers documented wildlife behavior to confirm that native species acted normally. Water samples were gathered from dozens of sites to verify the agent's concentration was already diminishing outside ingestion zones. Everything depended on careful, continuous observation. Each hour without negative signs added to the growing confidence in the technology's safety. The implications of such a breakthrough stretched far beyond python control. Environmental scientists everywhere watched closely, knowing that invasive species were a global crisis. Australia battled cane toads, Pacific Islands fought against brown tree snakes. Lakes across North America struggled with zebra mussels. Entire ecosystems teetered under the strain of biological introductions gone wrong. The possibility of precisely targeted biological management opened doors to solutions once considered impossible. Yet it also raised profound questions. Where should the limits lie? When did intervention become overreach? How could humanity wield such tools responsibly? For Florida, the immediate implications centered on ecological stability. If the python population could be reduced dramatically, prey species would have a chance to rebound. Marsh rabbits, small deer, foxes, and wading birds might regain lost territory. Predators such as panthers and bobcats could thrive again with renewed food sources. Even the vegetation, long pressured by altered grazing patterns, might recover. The Everglades wasn't just a swamp, it was a complex tapestry where every creature influenced the entire system. Restoring balance meant more than removing an invader. It meant giving the ecosystem space to heal. Communities that lived alongside the Everglades felt those implications personally. For years, residents described seeing fewer native animals and encountering more pythons near their homes. Pets vanished. Livestock suffered attacks. The psychological weight of living near invisible predators slinking through the marsh affected daily life. The release represented the first real sign of hope that the Everglades could return to a semblance of its natural identity. The scientific world approached the development with a mixture of admiration and caution. Geneticists marveled at the precision. Ecologists scrutinized every potential ripple effect. Ethicists wrote lengthy analyses about the responsibility of altering biological interactions in the wild. Lawyers debated the legal framework for future uses of similar tools. The initiative had inadvertently launched a new field of conversation that blended cutting-edge genetics with environmental stewardship. In academic circles, the Florida release became a case study almost overnight. Students dissected its methodology. Professors debated its long-term implications. Panels convened to discuss the balance between human intervention and natural resilience. Some argued that modern ecosystems were already so altered by human influence that targeted correction was not intrusion but responsibility. Others warned that reliance on genetic tools might encourage complacency in preventing future crises. What unified these voices was a shared acknowledgement that the python solution marked a turning point in conservation strategy. Meanwhile, indigenous communities with ancestral ties to the region weighed the development through a cultural lens. Their relationship to the land extended far beyond scientific definitions. They recognized the harm the pythons caused, but also emphasized the importance of humility in approaches to nature. Many supported the release, but insisted that long-term restoration must involve not just biological tools, but renewed respect for the land and its rhythms. Their voices shaped discussions about broader stewardship and the moral responsibilities entwined with ecological decisions. The financial impact carried its own significance. Python removal had cost Florida millions annually. Rewards, traps, patrols, research grants, and public outreach represented an enormous investment with limited results. An effective internal agent promised a future where those funds could be redirected toward habitat restoration, climate resilience, and endangered species protection instead of endless python control. Legislators observed closely, aware that success could shift how environmental budgets were allocated nationwide. While the event unfolded in Florida, global conservationists paid rapt attention. Many ecosystems struggled with their own invasive burdens, and the outcome of this initiative could influence international policy. Nations discussed the merits and risks of adopting similar strategies, though most vowed to proceed with extreme caution. The Florida model demonstrated that targeted biological intervention was possible, but replicating it without the same depth of oversight could be disastrous. The implications were powerful, but not universally replicable without rigorous scientific frameworks. As time passed after the release, researchers continued examining environmental data with unwavering diligence. Every shift in species activity, every fluctuation in water quality, every observation of reptile behavior was carefully documented. Each piece of evidence helped illuminate how the agent interacted with the broader system. Although the agent itself was designed to deactivate quickly, the ecological ripples of python reduction would unfold over months and years. Discussions about future applications emerged cautiously. Specialists debated whether similar agents could be developed for other invasive reptiles, or whether such technology should remain strictly limited to extreme scenarios like the Burmese python crisis. The potential was undeniable, but so was the responsibility to avoid normalizing biological manipulation. The more effective the technology proved, the more urgent the need for robust regulatory structures to guide its careful use. The release also spurred renewed conversations about prevention. Scientists emphasized that no amount of innovation could replace the importance of keeping invasive species from entering ecosystems in the first place. Pet trade regulations, improved enforcement, habitat protection, and public education remained foundational pillars. The python crisis was a warning that reactive solutions, even brilliant ones, were no substitute for proactive stewardship. Environmental groups that had long fought for the Everglades' survival found themselves navigating unfamiliar emotional terrain. Many had campaigned against chemical eradication methods, fearing harm to native wildlife. The precision of the biological agent gave them cautious optimism. They acknowledged the profound need for intervention, but reminded the public that true restoration required ongoing commitment. Killing pythons was only one step in healing decades of ecological strain. As analysis continued, experts discussed the cultural implications of wielding such advanced ecological tools. Society had always shaped landscapes through infrastructure, agriculture, and environmental management. But shaping the biology of an invasive predator introduced an entirely new dimension. What did it mean for the future of conservation? Would the public begin expecting rapid technological fixes for complex ecological issues? Could the line between invasive species, control, and broader biological manipulation become blurred? These discussions underscored the importance of transparency, education, and ethical reflection. The python agent might have been one of the most carefully designed biological tools ever released into a natural environment, but its significance reached far beyond technical achievement. It challenged assumptions about how humans should interact with natural systems, especially when those systems were already altered by past human choices. Even as agencies continued monitoring the Everglades, conversations extended into philosophy, policy, law, and environmental justice. The release became a mirror reflecting humanity's evolving relationship with the natural world. It raised questions about responsibility, not just in terms of action, but in terms of restraint. The technology's success depended not only on scientific precision, but on social wisdom in deciding when and how such tools should be used. In Florida, the day of the release became etched in memory as a moment when necessity collided with innovation. The stillness of the marsh, the drifting mist, the silent airboats, and the weight of collective attention marked a turning point. Whatever came next would unfold gradually, shaped by science, nature, and vigilant observation. For now, the Everglades held its breath as the microscopic saboteur began its quiet work deep inside the invader that had reshaped its landscape. The implications of that moment radiated outward, touching every field that dared to imagine a future where precision biology and ecological stewardship walked a narrow path side by side. The attention surrounding the release soon expanded into the international scientific community, where researchers dissected the methodology with an eye toward refining future ecological interventions. They focused on the unprecedented collaboration that had unfolded between genetic engineers, wildlife biologists, environmental regulators, and field ecologists. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Florida's new python killing method and what happens next there? We want to hear from you. Thank you for watching and see you next time.